Thank you, Sophia. Many thanks for your kind introduction. Sorry that I cannot be with you at the conference in person, but as we planned, I'm very pleased to have my PhD student, Ms. Cai Chang, to presenting our work on behalf of my team. As you know, that Cai Chang has been instrumental in many aspects of the work to be presented, including many of the user studies involved. So although she's doing her PhD in our medical school, the Li Guangqian School of Medicine, she comes with a background in computer science and education. So I'm sure you will find the talk very interesting. So thank you.
Hello everyone, I'm Cai Chang. Today I will share our experience in developing a medical AI curriculum. This work brings together three parts. Firstly, we developed an AI competency framework. And secondly, based on the framework, we developed an AI training program for medical professionals. And thirdly, the pilot implementation tests the feasibility of the design. Here is the outline of today's talk. We will begin with the background of you can see the rise of AI in healthcare and the growing demand for so-called bilingual professionals, those who can understand both the medicine and the AI. And then we will discuss the main problem, the lack of structured medical AI education. Next, I will introduce our medical AI competency framework, followed by how we use it to guide the postgraduate program design. And we will then look at the pilot implementation and the feedback we received. And finally, we will end with some lessons learned and the future directions. Here is two related publications. One is published in AIED and another one is in AAAI. Both are the top conference in the field of AI for education. Now let's move to the background. As we all know, AI is transforming the healthcare in many ways. It has a lot of benefits such as help with the early detection of diseases, the personalized medicine, and the resource management. There is a rapid rise of AI in healthcare. According to the report, we can see that over 56% of the healthcare organizations have implemented AI in some companies as of 2021. And 94% plans to do so by 2024. Similarly, about 50% of the healthcare providers in APAC region plan to invest generative AI applications. However, less than 10% of teach professionals in APAC possess both AI and healthcare skills. There is a gap. We need medical professionals who can understand, evaluate, and use AI safely and effectively. Therefore, calls for structured AI training in medicine are growing. For example, in the UK, over 80% of the doctors support formal AI training. And similarly, in Canada, Germany, and Tokyo, over 16% of medical students want AI into curricula. As emphasized by Mexico, AI is not meant to replace medical professionals, but the ones using AI will probably replace those who don't. In Singapore, we can also see this trait. Singapore is growing its pool of bilingual talent to transform healthcare using AI. For example, Singapore is addressing this global gap through some actions such as the AI apprenticeship program. Here is some current state of the AI in medical education globally. Table 1 shows some existing AI training programs in medical education. For example, Stanford has an online course called AI in Healthcare. And similarly, in Singapore, NUS has a 30 weeks online course which teaches AI for healthcare. However, most offerings are ad hoc workshops or elective modules without alignment with clinical competencies, instructional design framework, and evaluation for effectiveness. In summary, findings reveal a lack of standard AI curriculum framework and notable global discrepancy. To advance the AI competency development, UNESCO proposed an AI competency framework. It provides a global guideline for general education, which has 4 dimensions. The first dimension is human-centered method. This one focuses on cultivating a human-focused view on the benefits and the risks of AI for societal and environmental needs. The second one is ethics of AI, which focus on the developing social and ethical abilities to navigate and apply principles regulating human behavior across the entire life cycle of AI. The third one is AI techniques and applications, which focus on the integrating conceptual knowledge and operational skills through practical use of AI tools in real-world tasks. And the last one is AI system design, which focus on the building comprehensive engineering skills for the problem-solving, system architecture, and optimization of the AI system. Although the UNESCO's AI competency framework provides a global guideline and a starting point, it is too broad. This brings to our research problem. Despite interest, current AI in medicine is underdeveloped. Here are 2 main gaps. The first one is a framework gap. The current UNESCO's AI competency framework lacks the clinical context alignment. And the current program levels are built on a journal one, which however, the Miller's parameter of clinical competency is designed for doctors. And second is the course gap. Fewer studies address emerging topics like generative AI and data governance, despite their rapidly growing impact on healthcare practice. And secondly, fewer studies have applied validated curriculum development models to design AI training programs in medicine. To solve this, we defined 3 objectives for our study. So firstly, we develop and validate a medical AI competency framework that adapts the existing international guidelines to the specific needs of a clinical practice. And secondly, we design and evaluate an AI in medicine program. And thirdly, we conduct a pilot implementation of the program and validate its feasibility. Taken together, this objective aims to pave the way for AI-ready medical professionals, advancing both education and healthcare. Now let's move to the development of the medical AI competency framework. We start by adopting the UNESCO AI competency framework as our foundation. This one provides a global guideline, and then we restructure it based on Miller's parameter, which is a popular guideline for medical skills development. Specifically, it has 4 levels. The first level is knows, which means students know basic knowledge. The second one is knows how, which means students know how to use the knowledge. And the third one is show how, which means students show how they use the knowledge. And the last dimension is does, which means students can do in the clinical settings. After we build the initial AI competency framework, we validate and refine it through the expert review. Specifically, we collect insights from 24 domain experts from AI, education, and medicine. Here you can see the structure of the final medical AI competency framework. It has 6 dimensions, and each dimension moves up through Miller's 4 levels: knows, know-how, show-how, and do. Now let's move to the details about the framework. So, the first dimension is patient-centered AI in healthcare. It emphasizes patient-centered decision-making in AI-assisted care. The second one is ethics and transparency in clinical AI, which focus on applying AI responsibly and ethically in healthcare, with clear and transparent decision-making. And the third one is technical proficiency in medical AI applications, which focus on the understanding, using, and co-creating AI techniques effectively in clinical settings. And the next one is data prevalence, security, and compliance in healthcare AI, which focus on protecting patient data and ensuring AI systems follow privacy laws and some standards. The fifth one is bias mitigation and health equity in AI design, which focus on promoting fairness and equity-aware AI design to reduce the disparities. And the last one is generative AI for healthcare. This one focuses on understanding, using, and overseeing generative AI in clinical settings to ensure reliable integration into the real-world workflows. So in summary, we can say, based on the UNESCO's AI competency framework, you can see the right one, we built a 6-dimension medical AI competency framework, which cater to the clinical needs. Now, let's look at how we translate the framework into an actual curriculum. Specifically, we followed current 6-step approach, which is a well-established model for curriculum design in medical education. So for the first step is problem identification and journal needs assessment. Here, we identified the key gaps between AI and medicine, as well as some main AI topics in medical education. Secondly, we conduct target needs assessment. Specifically, we identify the student, hospital, and medical fields needs. And the third is about the goals and objective. Here we design the journal goals and the specific learning outcomes. The third step is educational strategy. Here we use different educational theories to facilitate the learning, such as problem-based learning, blended learning environment, as well as interdisciplinary learning. And fifthly is about the implementation. Here we implement our course. And finally is about evaluation and feedback. Let's begin with the journal needs assessment. We collect the input from hospital administrators, university instructors, as well as healthcare professionals. Across all these groups, we identify some similar challenges. The first one is the lack of AI appetite among the clinicians. Many want to use AI but don't know where to start. And the second is that difficulty tolerating AI solutions for local needs. And the last one is concerns about data privacy and ethical use of AI. These issues clearly point out to one thing. We need a target AI training program in medical education. So based on the different stakeholders' insights, we identified the 5 main learning topics. The first one is AI fundamentals. Here, we introduce some fundamental fundamental knowledge of AI. The second one is AI governance, which is about the regulatory frameworks governing the medical AI and the strategy for ensuring responsible AI use. The third one is AI ethics, which will about the ethical issues of AI in healthcare. The fourth one will include some hands-on sections in developing AI models for the clinical settings. And the last one is clinical applications, which is about evaluating and using AI for clinical decision-making and enhancing the patient care. Next, we conduct a target needs assessment through the surveys with 6 hospital administrators, 8 university instructors, and 10 healthcare professionals. So we identified the 3 different needs. The first one is the student needs. It includes 4 main topics, which are understanding basic AI, developing advanced skills, using AI in medical decision-making, as well as the career path and continuing education. For example, a hospital administrator side, the most important skill for the healthcare professionals to learn through this course is AI literacy. And it forms the foundation for the understanding and using AI technology in clinical practice. The second need is the medical field needs. It includes 3 topics, which are strengthening interdisciplinary collaboration, advancing ethical and regulatory policy, as well as increasing AI adoption. The last one is the hospital needs, which include 3 themes. They are the enhancing operation efficiency, improving patient care and treatment outcomes, as well as optimizing the cost management. To achieve these goals, we combine several educational strategies. First, we use blended learning environment and flipped classroom. Here, the student can learn some basic AI competency and knowledge through some online modules before the class. And in the class section, they will focus on some hands-on activities and more interactive case studies. After the class, the student will finish a project. Besides, to facilitate the learning experience and engagement, we also use the Kelbos model, which includes 4 stages. So firstly, students will have some hands-on activities, such as some lab sessions using AI tools in medical scenarios, as well as some real-world AI case studies in healthcare. After that, students can move to the reflection objective. Here, the student can conduct some case discussion in their groups. And then the teachers will have some lectures on some basic principles and facilitating the abstract conceptualization. And finally, students can do some project, and here they can facilitate the active engagement. Besides, we also engaged the problem-based learning. Students work on real-world AI problems from clinical context and develop solutions in the interdisciplinary teams. Finally, we also include the TBL, team-based learning, which is widely used in NTU's teaching. It allows the student to learn basic knowledge pre-class and discussion, as well as do teamwork during the class. This slide shows an overview of our AI in medicine curriculum. It is a 1-year postgraduate program composed of 4 core courses and 50 modules. Each module follows the same pattern: online preparation, interactive class, and a project. This slide shows the overview structure of the AI in medicine curriculum. So we can say it includes 4 categories. The first one is Medical AI core course, which includes some course like the Healthcare AI Governance, as well as some course like the AI in clinical decision support, and so on. The second one is a Data Science Foundation course, which includes some curriculum such as healthcare data analysis, and as well as the programming and software development for healthcare AI. The third one is Applied Medical AI course, which will teach students some basic skills about the patient safety, trust, as well as some AI for personalized care. And the last one is a more higher level course, which is about teaching students some advanced medical AI course. It includes some machine learning technology, as well as, for example, the deep learning, natural language processing, as well as medical imaging. We can see each module is mapped to a dimension of the medical AI competency framework, as shown in the last column in this table. We then evaluate the program through the expert review from both the industrial and academic. Feedback are positive. So firstly, we can say we conduct the evaluation with industrial experts. For example, we include 5 industry reviewers from diverse backgrounds like computer science, medicine, and education. And this expert evaluates its course content and structure, as well as the potential popularity of the course. And we can see, for example, this expert found that the curriculum is well structured and relevant to the healthcare needs. Besides, we also have an academic affairs committee to review and evaluate our program. Specifically, we have 16 members. It includes administrators from leading medical schools in Europe and Singapore, as well as representatives from Singapore's government department. Then we summarize the 4 themes of the AAC feedback. The first theme is this course addresses a critical skill gap. It empowers medical professionals to become proficiency AI user and co-creator. Secondly, it provides a comprehensive curriculum, which covered some key aspects of healthcare AI, from the programming to AI governance. Thirdly, it meets a market need. It was designed for the healthcare sector, unlike existing some AI programs. And lastly, this course offers flexible learning options. The modules and online delivery structure support working professionals. And actually, we will begin offering the master programs in August 2026. To validate our framework and the curriculum, and to understand how learners engage with the content, we conduct a mini hands-on workshop covering some key topics. Specifically, we conduct a 1-day workshop with students from LKC Medical School, as well as 3-day workshops for the students from Chinese University. And the number of the students is 28 and 19 respectively. Sorry. And both the teaching language is English, and the focus is about topics like overview of medical AI, programming engineering, data processing and analysis, machine learning, as well as AI ethics. Here is an overview of our hands-on training workshop. We can see, firstly, we will teach students some knowledge about overview of medical AI, And this is related to the AI competencies such as patient-centered AI in healthcare. Here, students can learn some basic AI knowledge. Secondly, we will teach students some basic AI skills, such as prompt engineering for Python programming, as well as data processing and analysis. After students have some basic AI skills, we move to a medical AI project. Here, students will have some hands-on activities, and they will learn some AI modules and the metrics for evaluating them. And then they will build their own modules to solve the specific healthcare problems. And finally, we move to the reflection part. Here, we will teach some AI limitations and considerations. Students will discuss on AI trustworthiness, interpretability, and uncertainty estimations. And we can see each module is related to the AI competencies from our framework. And during all the class, the student can use generative AI to help with some basic programming. Here is some student feedback on our workshop. So our workshop survey shows that students have high scientification and strong engagement, such as behavior engagement, emotion engagement, as well as cognitive engagement. And students also show some positive self-confidence. Here is some examples of the student response. For example, most of the students think that this course is very useful and the teaching method and material can facilitate their learning. And also, many students found that they can connect the learning with their own medical experience. We also collect some qualitative feedback from the student, and we summarized in 3 key themes. The first is that the student report they improved understanding of some coding basics, AI applications in medicine, and fundamental machine learning concept. Secondly, most of the students appreciate the instructor support and interactive environment. And they also have some suggestions. For example, some students recommend adding some more practical and research-related AI applications. And we also collect some teacher feedback on the hands-on training program. Specifically, we summarized 2 instructors' feedback. So the first is about the teaching effectiveness. Both the teachers said that the student engaged and interested in this workshop, and the hands-on section is interesting and useful. However, some advanced concepts and some tasks were challenging. And secondly, regarding the learning objective, both the teacher sides and some core topics are mostly achieved, such as prompt engineering, AI overview, data analysis, and basic modeling. However, some advanced technology, such as gradient descent, are partially met. And this course has 3 strengths. The first one is it offers an interactive and some hands-on sections, and it related to the healthcare applications. Besides, the teaching team keeps the student motivated and engaged throughout. However, there is also some challenge and suggestions for the future implementations. The first one is we need to simplify some technical context for non-coders. And the second one is that we need to provide clear instructions and support for the experts and teaching resources before the class. In summary, here is the contribution of our study. So firstly, we develop a medical AI competency framework which have 6 dimensions. This framework can guide us what to teach. And secondly, we design an AI in medicine curriculum, which include 50 modules. This one inspired how to teach. And finally, we conducted the pilot implementation through 2 workshops. This one can insight us how to implement. And in the future, we will implement a year-long postgraduate program in AI in medicine. And we will also use some advanced model to evaluate the long-term impact. For example, we can not only evaluate the student reaction learning behavior, but also evaluate some long-term results, such as measure the long-term organization benefits. And here is some relevant reference, and thanks for your listening.
Okay, thank you very much, Chai Chang, for taking us through the presentation. So I'll just like to share again that there's a QR code that you can scan, okay? And this is now the Q&A segment, okay? So I thought that was very insightful, and of course, as you may have noticed, okay, the course will actually be running in August 2026. So there may be some among here as well who might be keen to attend. Okay, I know that I would be for sure because of the comprehensiveness and the groundedness of the program itself. Okay, currently I think there are no questions coming in through Mentimeter, but of course it's best to hear from the audience in person. So just like to open the floor to any questions that you might have regarding the program or how Miller's Pyramid, for example, was applied. Okay, there's a question that just came in. For the rest, feel free to submit your questions as well. So maybe I'll direct the question to Chai Chang. The question is this being applied to LKC Med students currently?
Yes, this will happen in August 2026, and it's a year-long postgraduate program.
Okay, hopefully that answers the question. I believe there were also some trial pilots as well that Chai Chang shared about for the students, and that received rather positive feedback as well. Prof Fan is also joining us online, as you can see. So do let us know as well if you have any questions for Prof Fan. Yes. Okay, we have a question from the audience.
Hi, thank you very much for the presentation. Because AI changes so fast, right? And also the industry is also changing at the same time. AI models are being introduced into medical practice in the hospitals gradually, no doubt. How are you intending to change and update the course over time? What are the more stable elements you think? And what are some of the elements that you think will need a lot of continuous updating of the module? Appreciate your experience and insight in the curricular design. Thanks.
Okay, I think Prof Fan will take the question.
Yes, thank you. Can you hear me?
Yes, yeah, we can hear you.
Okay, great. Thank you. Thank you for this very insightful question. Yeah, indeed, we are in a very fast evolving stage for AI development. Before answering the question directly, I can give a very quick background on the development of the course. So everything was started at end of 2023 and the beginning of 2024. So the initial thing which I did was interviewing my colleagues, many of them, at the NHG, National Healthcare Group in Singapore. So I have met many clinicians, nurses, doctors, medtech developers, as well as hospital administrators. So they all give their different perspectives on what are their challenges and what are their needs. So those are the things forming the basis of the framework we developed and the course we are going to teach next year. So fundamentally, it is about understanding people's needs and at different instances and in different contexts. It is very, very true, as you mentioned, that technology is developing rapidly. However, if you look at what do people need and what do people really need in their work and what are the challenges they solve, you see that the pace of change actually is somewhat slower. So the challenges people faced many years ago may appear or reappear again today, but in different forms. So by understanding the basis on what is needed, we have a better understanding on what we need to teach. So if we look at the current curriculum, which Cai-Zhang has briefly presented, as you can see that many of the principal things they stay. Ethics, AI ethics or medical AI ethics, they stay. Principles for dealing with privacy, security, those things, they stay. And when you're talking about the actual AI development, yes, indeed, we have new models every week. But if you ask the concept of supervised learning, unsupervised learning, those concepts stay for more than a few decades. So it is very much true that we need to always embrace the newest and latest technology. And as a curriculum developer, we need to continuously updating our curriculum. But at the same time, we should always have a very robust core foundations to be developed for our students. So as a program developer, as a program director of our LKCMedicine medical AI program, my duty, at least to my understanding, is to show my student a map of AI. It may not covering the latest and the greatest models or innovation, but I should teach my student here are the important things in this area, and those are the key techniques. So as long as students are equipped with such a map, they can continue their own learning after living with us. Yeah, that's my take.
Just want to check with whether you have any responses to that. Do you want to further dialogue with Prof. Fan? Yeah. If not, thank you very much, Prof. Fan. I think what you have shared is very insightful. I think starting from learner needs, talking about concepts that will remain relevant regardless of how the age of AI changes, as well as also promoting self-directed learning, I think, in the learner, right? Taking agency, knowing that we are not reliant on the teacher to teach us what there is to know, but also understanding that in this age of AI, where I think accessibility, right, to AI is key, there's a lot of learner agency involved as well. Thank you. I don't see further questions coming in at the moment, but feel free to raise your hand and we'll come over with the mic. I do have some questions as well that I'd like to ask. So if I can just share this question, right? So the framework adapts UNESCO's AI competency framework into Miller's pyramid. So what were perhaps some of the biggest challenges in making, such a global framework clinically relevant? Yeah. Cai-Zhang? Yes. Okay.
So the UNESCO's AI competency framework, it provides global guidelines. But the most important thing and the challenge is how to make it adapt to the clinical needs and how to make it cater to the clinical needs. And to solve this, we based on the Miller's parameter models, which can support the medical skills development. So it shows how the student know how, show how, and do. And after that, we also invite some experts from medicals to validate and refine our framework. So in summary, we can, based on the global guidelines, to build a tolerated competency framework for medical needs.
Thank you very much, Cai-Zhang. I just have a question, right? So I know that you have engaged, the clinicians and many different healthcare professionals from all areas actually. So how did they generally respond? What was their response like? Is it excitement to this, emerging areas such as Gen AI and governance, everything that you want to put in? Or was there perhaps, did you sense any resistance or, different perspectives that came up in the course of engaging these clinicians?
Yeah, actually we heard different insights. So some doctors say that they start to use large language models like ChatGPT in their work, but they also found some challenges. One is hallucinations of the ChatGPT. Some large language model may give some misinformations, and in that time they need to evaluate and know when to use and when to don't use. And secondly is about prompt engineering. Some doctors mentioned that how to write a good prompt for the GPT and how to have a better response is also an important thing for them to learn.
I see, thanks. So it looks like, engaging AI, including AI, is inevitable. So it's a manner of, I think the dispositions that you shared is understanding AI limitations and how to overcome them, rather than, a staunch no to AI. Okay, thanks for that. I think in the interest of time, we also have another engaging presentation coming up from the Shanghai perspective. So on behalf of everyone, I'd like to just thank Cai Chang as well as Prof Fan joining us online. Thank you.